Hello friends, let's continue our discussion about designing an optimal matching order engine. So in the our first approach we have discussed in the previous videos is that using a linked list, a very plain linked list, and we have already implemented the matching algorithm along with the cancellation of an order and how to send the market data for level 1 and level 2. So this is all we have covered in the previous videos. And for the amendment of orders, we have discussed about 3 use cases. The first one was amendment on only quantity, and the second use case was amendment on price only, and the third use case is amendment on both quantity and price. Just beware of that whenever we are changing the price, right, in that case a matching is possible, because suppose if you are increasing the price of a buy order while doing the amendment, in that case there's more possibility that increased buy price should have a corresponding matching order for a sell. Similarly, for the sell order, if you're doing an amendment for price down, then also matching is possible. So all these cases we have discussed. So in this video, we are going to do the last use case in which we are going to do amendment on quantity as well as price in the same order, order cancel replace request. So as seen here, we have got we have this interface order book I, in which we have got these 3 use cases. First one was amendment on order only for quantity with a new quantity, then amendment of order only for the price, and the third one, which we're going to cover in this video, is for both quantity and price. So our first implementation using linked list is quite similar to what we have done previously for amendments for price and quantity only. So this is the method, overridden method that we have implemented. It's exactly same as what we have done for, say, price, amendment on price or amendment on quantity, right? So it's very much similar. So again, let's go through it. So as soon as we receive this amend order request, then first of all, we'll check that whether this order ID does exist or not in our order cache. Because if there is no order ID, then in that case, order was not received before, so this is not a valid amendment request. So this is the first check that we'll do. Other check that we can do is that the quantity that we are going to amend, that should be not less than 1, and even the price should not be less than 1. So all these like basic preconditions that we'll check here. And if anything is not validated, then we'll throw a illegal argument exception. So guys, this is always a best practice that whenever you're trying to to implement any method, and if you're passing any arguments which doesn't match or which is not valid, always do the precondition checks as the first point, as the first step whenever we implement any type of method. Okay, so once we are done with this, it means that order does exist. Then we will get it from our order cache, and then we will set the new quantity and also the new price that we have got in this request, which is always an O1 operation. After that, as we have implemented before that, whenever you do any amendment, first of all, we remove the previous order from our cache and then add the new amended order in the cache back. So this is what we are doing here, remove and add order. This is what we have done previously as well for the other use cases for amendment. So the remove order, as we've seen that for the remove order, it is an ON operation because first of all, as we go to the remove order, this is the implementation here. First of all, we will take the ID and then remove it from the cache. And after that, because we are maintaining 2 linked lists here, one for buy orders and one for sell orders, so we have to iterate through all of the, like, from the head to the tail, whenever until we find that order that we want to remove, and then we have to remove it. So as per the linked list, it is always a ON time complexity. So that's why the remove order will take ON. And for the add order, once we have removed the previous order and then now we add the amended order back to our cache, we have learned it that for this, first of all, we'll do the matching first. This is for matching, that whenever after changing the price of, say, buy order or sell order, after that there's a possibility that it can match, right? So we have discussed this in detail, that how the matching will work, and this will be taking, it can take O1 time, or it can take O of the end of time, because every time it will try to get the best order from the opposite order. It will always try to match it first and then add it back. Whatever order is not added, or whatever order is not matched, it will be added back to the order book. And that's where the time complexity, because we are going to sort it every time, that's why the complexity would be always n log n. So whenever we are adding any order, first of all, we have to match order first. There's possibility of matching because we are changing the price. and whatever the unfilled quantity is there, then we have to add that order back to the order book. And that we have learned is that every time it involves sorting, and sorting always take and logn complexity in case of our linked list. So this is all about the implementation. Let's go back to our amend order implementation. So this is our amend order implementation where we are doing for both quantity and price. And as we have seen that the remove and add order, it takes overall complexity of and logn. So the overall complexity of this whole amendment will be O(n) of logn. So, and after that, once the order is amended, then it will print it out. So I got a similar use test cases. For test order amend quantity and price. So as we have discussed previously about this test case, it will first of all try to add the order book, which will be looking like there would be 3 buy orders and 3 sell orders. For example, this one. So our test case will generate this order book first, in which we can see there are 3 sell orders at the top, and then there are 3 buy orders at the bottom. And this is like the current state of the order book. Now let's go back to our test case. So once we build that order book, so just to again revise it, we are doing it here in the setup. I am creating this once, and it will print order book same as what we saw here, 6 order resting in our order book. Now let's go back to our amend order quantity and price test case. So once that order book is done, then we'll send a new order of say by price of 200, and then we will also show that whenever we add this new order, it will be just resting in the order book. Then we'll print order book. After that, we'll send this amendment request in which we are going to increase the quantity from 200 to 250, and also the price from 10 to 20. And after that, we'll again print the order book. In this scenario, I'm just keeping it very simple, that it will not have any matching, and it will just rest in the order book, so that I can show that that this amendment works and it is resting in the order book. After that, I'm doing just some basic assertions that the order which I have amended, that is having the new quantity of 250, and the new price is 20. Okay, so let's run this, and then we'll see that how it works. So as seen here, just run this test case. So first of all, I set up the order book in which we have got 3 sell orders and 3 buy orders, as we discussed in this diagram. After this, we are sending a buy order of 200 at 10. So buy order of 200 at 10. This is our buy order at 200 at 10, which is just placed in the order book, and it is having the least priority because the price is the least of all the other buy orders that we have. As we know that for buy orders, more the price is having the more priority, and for sell it's opposite. The lower the sell price, it would be having the higher priority. So here we have got the higher priority of this order ID2 for sell, and for buy orders the highest order is order ID 5 with price 20.2. Okay, so this is our order, and now we are amending the buy order quantity from say 200 to 250, and price from 10 to 20. And so order is amended, and this is our new order which has been amended with the given price and quantity after amendment. And if we look out at our order book, this is correctly amended and placed in our order book, showing price as 20 and quantity as 250. So our amendment is working as expected. Now guys, we have done with our first approach using a one-dimensional linked list, and this is our performance metrics that we can see. Whenever we try to add any order to the order book, it always take O(n) of logn, because every time we are sorting it. Similarly, matching will take in the worst case as O(n), because every time when we try to take the head of the linked list, it is always O(1). But if we keep on iterating it, the matching can happen for several orders, so it would be the worst time complexity would be O(n). Similarly, cancellation will also take O(n), because every time it has to search from the head to the tail, and until it finds the order, only then it can cancel that order. That is again O(n). And for amendment, quantity, price, and both quantity and price, it's all O(n) logn. As we can see that the biggest bottleneck of using this linked list is, although it's almost perfectly correct, the implementation is correct, but performance-wise, the main performance hit that we are getting is when we are trying to add the order to the linked list. We're trying to add the order to the linked list for buy orders and sell orders. Every time we have to sort it, and for sorting, it is taking this n logn. So this is the biggest, I would say the performance bottleneck that once we use linked list, that the sorting in most of the cases it's always like n logn. The only best part is that when we are trying to match the order, In the worst case, it can only go to O of n, because every time when you're trying to match it, we are trying to get the head of the order or of the opposite order to match, which is always O1. In that scenario, this scenario only, this linked list data structure is very good when we are matching the order. Now we are done with this first approach of using linked list. In the second approach, we are going to use priority queue, in which we will try to improve this O and logns of sorting to O of logn. So see you all in the next video when I will try to use the same approach, same matching engine algorithm using priority queue.